Okay, guys, happy day 7 of your math. All right, we are going to be spending all week for the rest of the week on understanding how to solve different types of volume. Okay, so today we're just going to learn how to understand the concept of volume, and then your assignment afterward is pretty simple. All right, so today should be an easy day. So just pay attention and we'll get through this. So today you're at the bottom of your sheet, day 7, lesson 11.6, understanding volume. We are starting on page 669 right now. All right, let me get that out of my way. And if you all will join me, we'll start here. At the top of the page. It says that you can find volume of a rectangular prism by counting unit cubes. All right, so we're going to talk about the unit cubes today. Obviously, we're not using them. We don't have them, but we're just going to talk about them. We can see them. They're right there on the page. All right. And then later on, we'll talk about using volume as a formula. So we're not going to be doing that today. That'll be one of the other days this week. So volume is the measure of the amount of space a solid figure occupies and is measured by cubic units. Okay, what does that even mean? So let's take our example from yesterday. This box. All right, so if I were to take a bunch of tiny 1 inch by 1 inch cubes, I'm asking myself, how many of those can I fit inside of this box? That tells me what this box is in volume by inches. If I did centimeter cubes, I would be trying to solve the volume by centimeter. So it's how many of those could I fit inside the box. Okay, you know the area is like the face, like the of a just one plain figure. How many squares fit on the face of that figure? Perimeter is the distance outside of just a regular figure. Volume is when we turn three-dimensional and we want to know how many cubes fit on the inside of one of those figures. So that's what we're going to be doing today. Now, we are not doing any specific measurements today, so we're just going to talk about units. And when it says cubic units, that means units cubed. So remember when we talked about exponents, those are to the third power. So let's say we were measuring them in centimeters. It would be centimeters cubed, okay? Because that's how many cubes it takes to fit inside of the shape. So always, 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 when you're talking about volume, mark it units cubed when you're done measuring it, or else we don't know you're talking about volume. Okay, so now let's look down here at this problem. All right, it says the rectangular prism above is made up of blank unit cubes. So we're talking about this rectangular prism here on the left. It is made up of, there we go, it is made up of 8 unit cubes. All right, you count the front and the back. They split them up for you there so you could count them. 8 unit cubes. So that means it has a volume of 8 cubic units. Okay. If you were to write that, like I said, you could write it as 8 units cubed or that unit cubed, either way. But either way, you have to write it as cubic units. All right. Now, here for the activity, you can see it's telling us to cut and fold out a rectangular prism net. Those are the ones that when you have like the piece of paper and you fold it to make a three-dimensional shape, that's what they've done here. And it says to use centimeter cubes, which is what we have in class, to fill up that net. Now, we obviously can't do that. So what it's telling you is that each centimeter cube has a length, width, and a height of 1 centimeter and a volume of 1 cubic centimeter. So all the way around, it's 1 centimeter by 1 centimeter by 1 centimeter. All right. And it would want you to fill up the net that goes with this with all of those cubes. So I'm going to give you a scenario and we're going to figure it out. So let's say that we have a length of 5, a width of 5, and a height of 1 on that first layer. All right. So that's kind of what you can see there. They went across 5, they went back 5, and obviously they only went up 1 because they only did 1 layer. So how many centimeter cubes are used to fill the base? Well, in order to figure that out, all you do is multiply across 5 times 5 times 1. So how many were used to fill the base? Well, 25. All right, that's it. So if we continue to fill this rectangular prism layer by layer and count the number of centimeter cubes used to fill it, again, I'm going to give you a scenario so we can figure this out together. Let's erase so I can move down. All right, so that we can do C together. All right, so you know that each layer is already going to consist of 25, because if the first layer had 25, every single layer is going to have 25 because they're going to be the same coming up. So how many layers of the rectangular prism are there? There are going to be 5 layers of the rectangular prism as you go up, okay? Because what it is it's really a cube is what they're having you fill. So if you have 5 by 5 by 5 all the way around, what are you going to end up with? How many centimeter cubes are going to fill that? Well, of course, you're going to multiply 25 times 5. So take a second. What do you get when you multiply 25 by 5? Okay, you get 125. That's how many centimeter cubes fill the inside of that rectangular prism. Okay, and so the volume of that rectangular prism would be 125 cubic centimeters. All right. So, simple problem. You have to know how to multiply, and I have faith in you, so we should be set. All right, moving on to page 670. So number 1 says to describe the relationship among the number of centimeter cubes you use to fill each layer, the number of layers, and the volume of the prism. All right, so if we are talking about that, the number of centimeter cubes, so the number of cubes in each layer, we'll answer that part of the question first, was 25. Okay, so it's the first part of your question. All right, but then it asks you about the number of layers. So multiplied by the number of layers, which is 5, gives you the total number of cubes for a volume of 125 cubic centimeters. And that's how you can write that. Okay. So get that copied. Number 2, it says that if you had a rectangular prism that had a length of 3 units and a width of 4 units and a height of 2 units, how many unit cubes would you need for each layer? How many unit cubes would you need to fill the rectangular prism? So first, ignore the height. Okay, ignore the height for the first question. All right, so for the first question, each layer, you're going to do the width and the length to know what you need for each layer. So you'll need 12 for each layer. Okay, then you can start applying the height. Okay, because the height is how you're building going up. So if you need 12 for each layer, then you'll need 24 cubes it's supposed to be a T, sorry, to fill the prism. Okay, so 12 for each layer, 24 cubes to fill the prism. I'm going to start erasing. And we'll move on down to the next questions. Okay. So let's see, I can fit all that in there. There we go. All right. To find the volume of three-dimensional figures, you measure in 3 directions. For a rectangular prism, you measure its length, its width, and its height. Volume is measured using cubic units, such as cubic centimeters, cubic inches, or cubic feet. Which has a greater volume, 1 cubic centimeter or 1 cubic inch? Explain. So they show you over here a cubic centimeter and a cubic inch. Each are worth 1, but which one has a greater volume? Well, if you use your common sense, 1 cubic inch would have the greater volume because 1 inch is greater than 1 centimeter. So 1 cubic inch would have a greater volume. So they may both be worth 1, but when you start working in the actual measurements like centimeters and inches, you have to think about that. Because if I worked in something like a cubic meter, okay, and switching over to metrics, but a meter is so much bigger than an inch. An inch is this big. I remember yesterday I'm trying to show you a meter with my arm and I'm going off the screen. So you have to think about those kinds of things. So now it tells us here to find the volume of the prism if each cube represents 1 cubic centimeter, 1 cubic inch, and 1 cubic foot. Don't ever think this. You are going to do, remember, volume of a prism equals length times width times height. All right, and you're going to do 3 times 6 times 2. Well, 3 times 6 equals 18, and 18 times 2 equals 36. All right, none of those answers are going to be different. They're all going to be 36, but the centimeters one is going to be only 36 cubic centimeters, while the inches is going to be 36 cubic inches, while 36 cubic feet is going to be pretty big, okay? So with this prism above be the same size if it were built with centimeter cubes, inch cubes, or foot cubes? All right. No, it wouldn't. All right. Explain. And it wouldn't be, and I'll just talk you guys through this instead of writing all this down. You can write while I talk if you'd like, but a centimeter cube is only this big. All right, here, let's do this. So from here to here, from my finger to my finger, is 1 centimeter. Over here, from my finger to my finger, is 1 inch. Then from here to here is 1 foot. Now, if you put 36 of those together, I mean, I can show you 36 centimeters. That fits in the screen. I can pull out 36 inches. It doesn't fit in the screen, but I can show it to you. I can't show you 36 feet. There's not a chance, all right, that I can demonstrate 36 feet to you on this screen, all right? 1 foot is right here, the size of 1 ruler, all right? String 36 of those together, and that's 36 feet. So if you had a prism that had 36 of those 1 foot by 1 foot cubes inside of it, that's a pretty big space, okay? So what you want to think about, and this is what you can start writing, the prisms would have the same number of cubes inside of them, but all the cubes themselves would be different sizes, all right? So the centimeter one would be very small, the inches one would be right in the middle, and the feet would be very large, all right? So that's your explanation for that bottom question right there. Okay, and gonna erase. And we'll move on to the next page and do some problems together. Sorry, I thought I was going to make it. All right, we are going to do the whole page. All right, number 1. It says use the unit given and find the volume. So I don't have to count up the cubes. I can just multiply. Okay, so 4 times 4 is 16, right? So we did 4 times 4 times the height. 16 times 3, if you don't know your 16 times tables, write it out like this. What is 3 times 6? Well, that's 18. Write down your 8, carry your 1. 3 times 1 is 3, plus 1 is 4. So 48 cubic centimeters is how they're measuring it. Okay? Nice and simple. Here, remember, volume equals length times width times height. All right, here you're going to do 3 times 2 times 4. Well, 3 times 2 is 6 times 4 is 24 cubic inches this time. Okay. Number 3, 6 times 2 is 12. So you did 6 times 2 times 3. 6 times 2 is 12. Times 3 gives you 36. So you have 36 cubic feet. Okay. Here, you have 5 times 4 times 3. 5 times 4 is 20. And I know you don't know your 20s times tables, but you should be able to think about this one. 20 times 3, well, 2 times 3 is 6, and then you have that 0, gives you 60 cubic inches for this one. So, nice, simple problems here. Okay. 5 and 6 are a little bit different as to what we are doing. In terms of the directions, so we're going to compare the volumes with greater than, less than, or equal to. Oh, and you just have to find them first. So here you're going to do 8 times 2 times 2, and you can do 8 times 2 is 16, and you can do 16 times 2 because all you have to think, well, 16 plus 16, what does that equal? Oh, that's 32. Okay, they already put the measurement there for you, 32 cubic inches. And then you have 4 times 4 times 2, so 4 times 4 times 2. Well, 4 times 4 is 16. 16 times 2, that's also 32. So these two have totally different shapes, but they are equivalent as far as volume is concerned. Okay? If you were to actually count up all of these blocks, you would see that each had 32. Now, moving on down here, you have 9 times 4 times 3. Okay? Now, I don't expect you to do 9 times 4 and get your 36 and then know your 36 times tables and do 3. But I know that you could do 4 times 3 equals 12 and do 12 times 9 and know your 12 times tables. So 12 times 9 is 108. That way you don't have to do any extra work. So 108 cubic feet for the volume of this first one. And on the second one, you have 8 times 5 times 2. Well, 8 times 5 is 40 times 2. You can do 40 times 2. It's 40 plus 40 is 80. Okay. So 108 is greater than 80. Okay. So nice and simple on those problems. All right, so on your next page, guys, page 672, shorter assignment, not your big assignment for the day, but we'll go over that one in a little bit. So take a moment right now to do that, watch the Math on the Spot video, check that out, and I'll be back to go over that with you shortly, okay? Good luck.